Welcome back to our video series on statics. Today I'd like to follow up our barge question. So last session we looked at a barge being pulled by two tugboats. And if you recall, we set up simultaneous equations in the x and the y direction, and we went through all this math and we substituted back in. But what if I told you there's a better way to do it, or an easier, faster way to do this? I find this pretty exciting. Moreover, it doesn't just work with a couple simple problems, or these types of simple problems, but you can also extend it towards other problems where you have lots of vectors. This is going to be a topic on forced triangles. We're going to solve this problem and look at the basic idea of forced triangles. Now, let's take a look at our free body diagram. Right here, we know that we can, one of the neat things about vectors is we can add them. So let's try it. Let's imagine that we take force A. All right. Force A going here. And then we're going to take force B. That's going to come like this. We're going to add those two vectors together, force B. All right. Now, one of the things that we know is if we sum all the forces, remember this, we sum all the forces. Let's make something a little bit. That's going to be your total mass times acceleration. We know that this is not accelerating in any way. It's saying at a constant velocity in the x and the y direction. So we know the sum of the forces is 0. That means that if we take the force due to drag, it's going to put us back to our origin. A plus B plus force D is 0. Great. So what have we done besides create a triangle? Well, it's funny you should phrase it that way, because the fact is we have created a triangle. This angle is 30 degrees. This angle is 45 degrees. And because we know how triangles work, we know that this angle is 105 degrees. All right. How can we use this? Well, fortunately, because we're savvy with our trigonometry, we also know that the sine of A over A equals the sine of B over B. If you remember this, if we have a triangle, and we'll call this angle A, then this is side A. If we call this angle B, right here, this is side B. It's the opposite side. We can set up a ratio. Let's take a look at this. The sine of the angle opposite of force D, that's 105 degrees. I'm going to keep these colors so we can keep them straight. So sine of 105, and what's the length across from it? Well, it's the length of the vector, or the magnitude of the vector. That's 10,000 pounds. That equals the sine of B over B. All right, well, let's take a look at 45 degrees. 45 degrees, sine of 45. And the length across from the sine of 45, we don't know it. But we do know that it's supposed to be force of A. So in this case, we've set up our triangle with our vectors. We've used the law of sines to say that sine of an angle divided by the length at the opposite side is equal to the sine of this angle over this side. Or we could have done 30 degrees. I mean, heck, this is also sine of 30 degrees over force B. Take a look at this first one. We have one equation, one unknown, set up super easy. If I mean, we'll just go ahead and solve it. We know that force A equals 10,000 times sine of 45 over sine of 105. Let's bring up our calculator. Here it is. Still has our previous answer on that. So let's take 10,000 times 0.707. And then we'll divide it by 105 sine equals 7,319. So 7,319, let's see, what did we get earlier? Force of A was, here it is, 7,321. So that's due to all the rounding errors we made. Here, because we're doing it 7,319, because we're doing it in so few steps, less steps mean less rounding error. And we also did it on a calculator, so it kept track of everything. Force B, same idea, do the same setup. And if you do that, you'll find that the answer is 5,176. So in summary, one of the things we can do is this concept is known as a force triangle. And we say it a force triangle because very often we have 3 vectors and we have to resolve to find out what what some of them are with simultaneous equations. But you could also use this if you had like any type of parallelogram. If you can use the rules you know for polygons, you're able to use this concept to solve far more complicated problems. And in summary, we use our vectors to set up a triangle. We use the information we have about the angles and the magnitudes of the forces and the law of sines to find our missing component. This should show you that even though you may have already known how to do the barge problem by separating it into vectors, part of the statics course is to use more of our information to be able to do more complicated problems or the easier problems quickly and more effectively. I look forward to seeing you on our next video when we jump in further.